Ladies and gentlemen, we are here with 6th hour blended honors geometry here to do a live studio audience video of 11.8 Hero and Brahmagupta's formulas. Woo! Alrighty, ladies and gentlemen, here is Hero's formula. We have the area of a triangle, any triangle, not just a right triangle, where A, B, and C are lengths of the sides of the triangle, and S is called the semi-perimeter. So you add all the sides up, divide by 2, bippity-boppity, boo. You can plug that bad boy in and find the area. Woo! All right, before we get to the Brahmagupta's formula, we need to know what a cyclic quadrilateral is, and it's a quadrilateral that can be inscribed in a circle. All right, and the reason why we need to know this is because Brahmagupta's formula only applies to cyclic quadrilaterals or an inscribed quadrilateral. Lovely. Wonderful. All right, so Brahmagupta's formula, it looks very much like Hero's formula. However, we're dealing with 4 sides. There's no S at the beginning here, right? It's just the 4 pieces. We're still using our semi-perimeter of that quadrilateral, but it has to be inscribed in the circle. It has to be a cyclic quadrilateral, not just any quadrilateral. All right, we're going to find the area of a triangle with side lengths 3, 7, and 8. Now, we don't have to have this as a right triangle. We don't have to find a height and base and all that good stuff. Let's just draw out our triangle, 3, 7, and 8. And I can use Hero's formula to figure that out. So my semi-perimeter is 3 plus 7 plus 8 all over 2. So that's going to be what? 18 over 2, which is 9. Then I can plug that all into my formula here. 9 times 9 minus 3, 9 minus 7, and 9 minus 8. All right, lovely. So that's going to be what? 6, 2, 1. So that's 12 times 9, which gives me 108. Is that right? Come on, live studio audience.
What are you doing?
Now, if I can't leave this as my final answer. I do have to take care of it like a factor tree, and I'm running out of room over here, so I'm just going to pop it over here. 108 can break down into, I think 36 and 3, yeah?
Yeah.
So then I get 6 root 3. Units squared. Wonderful. Wow. Spectacular, the crowd says. All right, so we need to find the area of an inscribed quadrilateral with the following side length. So the fact that it says that it's inscribed means it is a cyclic quadrilateral. Okay, just another word for it. So I can use Brahmagupta's formula. First thing I got to find is my semi-perimeter. So 1 plus 4 plus 9 plus 10. So I've got 24 over 2, which is 12. And now I can use that in my lovely, wonderful, fantastic, and excellent formula. 12 minus 1, 12 minus 4, and 12 minus 9, and then one more, 12 minus 10. Alrighty. Let's figure out what's inside that square root. I wonder if my studio audience knows. Nope. That is not a 9. That would be 11 and 8 and 3 and 2. What do we get?
Square root of 528.
500 what?
28.
Cool. So we're going to need to break that down with a factor tree. What kind of perfect squares can I take out of that bad boy? Is it divisible by 64? I don't know. I'm gonna get my calculator going too. This is fun. Who's gonna get it first?
You.
Nope, it's not that.
Try 36.
We're gonna pause. So it is divisible by several things, but the one I'm looking for is 16 and 33. The reason why I choose that is because the square root of 16 is 4, and 33 cannot be broken down any further because it would just be 3 and 11, no perfect square. So boom. There's my area as a simplified radical, no decimals. When we say exact, that's what we mean. We have somebody with a cough in the audience. I'll have security escort them out quickly. Alrighty. So we want to find the area of this figure. Now this is the type of problem that will trip some people up, right? Because they accidentally use the wrong formula. Anyone know which formula I would use? The first one, Hero's formula. Why can't I use Brahmagupta's?
Because it's not in a circle.
It's not inscribed in a circle. It doesn't say that it is. So I cannot use Brahmagupta's. So I'm going to use Hero's to get the area of one triangle, and then I can just double it because it is the same triangle. It's got all congruent sides. All right, so my semi-perimeter is equal to 5 plus 10 plus 7 over 2. That would be what? 22 divided by 2 is 11. And boom, I can pop it into my formula. Sounds like people brought, snacks to the studio where this is being recorded. I don't know if we can hear the crinkling in the background. All right. So 11 times 1 times 4 times 6. Anybody in the studio audience? 264? Yeah? Did you forget the 11? Ah! Don't forget that 11. Alrighty. So, let's see here. 264. What can that be divisible by? Can we do by 16? Nope. How about 4 would then leave me with 66. And 66 is only divisible by 2, 3, and 11. So we are good to go. All right, so this will break down into 4 and 66. So 2 root 66 for one triangle, which means 4 root 66 for the whole thing, because I got 2 triangles. Isn't that right, John?
Yes.
Yes, John says. Maddie?
So for this one, we would only have to find one, and then you would just have to double it.
You got it, because we got 2 congruent triangles. We can't use Brahmagupta's because not in a circle. Not inscribed in a circle. America. Alrighty, so we got one last problem here. The final problem of chapter 11. Ooh. Ooh. Jake, what formula you thinking we finna gonna need to use?
Brahmagupta's.
Brahmagupta's. Why do you say that, Mr. Jake? It's inscribed in a circle. It's a quadrilateral in a circle. Excellent. So, of course, I got to find my semi-perimeter first, and then I can plug that bad boy in. So we've got our semi-perimeter here, which is 13. We can plug that into the formula. And when we do that, we get square root of 1,296, which is
36.
36. It is a perfect square in this case. Units squared, whatever that might be. Bibbity boppity boo, we done. Jake, how you feel about this one, brother?
Tired.
He's tired. Anybody ecstatic about this?
No.
All right. So much enthusiasm in the audience. All right, here's our homework. Don't worry about the exam date. That changes every year. However, these videos are timeless. Unless the math changes. What?
You said in the last video.
Yeah. So?
Change your catchphrase.
Change my catchphrase. I said timeless in the last one?
Yeah.
These, the exam dates change. However, the videos remain the same.
They're long lasting.
They're long lasting.
Those were
They go to infinity and beyond. All right, Costco.